Good afternoon and welcome to our webinar on AMRs and the demand for interoperability. We're going to get started here in a second as we let people join. We got a great lineup for you this afternoon. I'm really excited about the topic and what we're doing here, so can't wait to share more. All right, let me just give it another minute and then we'll get started. All right, welcome to this afternoon's webinar from MassRobotics on autonomous mobile robots and the demand for interoperability. My name is Tom Ryden and I'm the Executive Director here at MassRobotics. And for those of you who don't know us, MassRobotics is an independent nonprofit that supports the robotics and AI and IoT markets. We are very active in the space. We do a number of different things. We really enjoy opportunities like today, and so I'll talk a little bit more about that. We also, for those of you who don't know, we run a robotics innovation center in downtown Boston, where we house over 65 startups that are doing all sorts of different robotics. We have a number that are in the AMR space. And as part of our mission to grow the ecosystem and the demand for robotics overall, we started work on this interoperability standard about a year and a half, going on 2 years ago. Had some great input, and we've got one of the founders of MassRobotics and our president, Theobald, will talk a little bit more about that in particular. But we wanted to get started by really talking with a customer about the need for AMRs and more generally the demand for interoperability and why is there a need for that. So first up, we have our first speaker is Prat. And Prat, I'm sorry, I'm going to butcher your last name. PremSankar, is that correct? Hopefully. Prat is the manager of robotics software and mobile robots and automation at Procter & Gamble. Procter & Gamble is our newest partner here at MassRobotics, so we're really excited about that. We look forward to doing all sorts of really neat things with P&G. But I'd like to introduce Prat, and Prat, the webinar is yours. And now I can't hear Prat. So we start with our first technical issue. Nope, still can't hear you.
Okay. I was trying to unmute myself, but it said the organizer was still muting me. So, all right.
Sorry about that. Thanks.
No problem. So yeah, I'm excited to talk to you guys today about kind of what the need from the customer side is. For Procter & Gamble, we are basically a consumer goods giant, right? And we're focused on how can these AMRs help enhance our productivity and our speed.
Now, Prat, I can't hear you all of a sudden. I'm not sure what that.
Okay, I didn't touch anything. Is that we okay? Okay.
Yeah, we're good. We're good.
So the manufacturer is the one like we're looking at to produce these robots, provide the initial risk assessment and safety standards. We're all making kind of contributions towards looking and identifying at any residual risk that might occur at that point. And then the integrator is the one that we're going to say, hey, like we want to use these in our workplace. How can you help us get these robots working in our area and integrated into our system? And they're also going to be kind of addressing the residual risk that's first identified by the manufacturer. And then us as the end users, we're looking at basically doing the hands-on training for specific missions or integrating it into the system and doing a lot of the customization day-to-day activities for a lot of these robots and controlling the fleets for them as well. And then, so this is kind of looking at the use cases that we've seen across our company. The more popular use cases that we've seen so far is standard pallet movement for large amounts of material directly from the warehouse area to a staging area that's usually somewhere near the manufacturing line. However, this still requires manual unloading of that pallet to be put directly onto the line. We're also looking at material delivery to kind of the end of line manufacturing, right? So if it's possible to directly use a conveyor to get onto the line and get that material directly onto where we're all working, it makes it a lot easier. And lastly, some of the use cases that we're looking at require us to sample products in the middle of the cycle. So usually we'll have an industrial arm of some sort attached on top of an AMR in order to get that sampling and deliver it to a lab for testing. And kind of looking at the interoperability struggles and what we are struggling with here. The major ones are being able to interface with the environment and use these AMRs to communicate with the conveyors or the machines that we're depositing and picking up the material from. A lot of the times, there's a lot of custom interfaces for each vendor, and a lot of the customizability is helpful for that specific vendor, but then in order to integrate maybe another AMR or another unit from a different provider, it makes it so that you kind of have to repeat the entire process of that integration again. So it's sometimes hard to you can't use like a one solution for all. Integrating each and every robot is kind of its own experience, and it has its own struggles. So, and then when we have a couple of plants that are kind of using AGVs already to do a lot of this transportation, and when we try introducing AMRs into this ecosystem, when they're not able to see each other on a common map or any sort of recognition other than kind of, oh, it's there, but it doesn't actually know that it's another AGV or another robot, it leads to kind of stops at certain intersections where they're kind of crossing paths, and maybe they kind of get locked up in a certain way that requires us to manually intervene and then have to resume normal operation. But if they were able to see each other and communicate to each other and share their kind of travel paths or future travel plans as they're doing their travel and trips for delivering material, it'd make it a lot easier for having multiple different AGVs and AMRs working in the same system. And then kind of looking at the financial aspect for a lot of these projects, we have a lot of centers that are really excited when they see a vendor come out with an AMR that's at a very low cost or very low price range, and they get excited and they say, hey, can we get this, and it'll be super cheap and it's not going to be, you know, hard to test. But we've been doing some case studies across P&G, and some of the case studies that we looked at have shown us that when you're trying to kind of value out how much this entire project is going to cost, the actual cost of the robot only is a certain percentage of the time, like the total cost of integration. So a lot of times you have to pay for modifying the machine that you're going to be using the AMR with. You need to pay for the integrator to travel and also to do the work that is required to integrate these robots into the system. And sometimes if you need other additional devices or sensors, or if you need a separate person to be able to integrate with the WMS or material tracking system, that can also pose an additional cost. So I think the main reason and like motivation for being able to make it more affordable would be offering easier and better integration and allowing us to remove kind of some of these extra sectors that are adding to the overall cost of the integrating this AMRs into our ecosystem. Then it would make it easier for a lot more adopters to be able to get these machines and test them during their initial pilot stages as well. And we have like an early adopters group here at P&G, and we kind of get on a call on a bi-weekly basis to kind of talk about what our key struggles are, or kind of our experiences have been with working with different kinds of AMRs and AGVs in our plants. And these are kind of the major key points that we've seen be a struggle. So again, having the integration into a WMS or ERP system and being able to track the material and share that information without having to have a separate fleet manager outside of the vendor's own fleet manager, like having almost a middleman, that adds extra cost. So being able to do that directly would be a great help. And again, shared / mixed fleet management. So looking at AGVs or even other AMRs, I know a lot of vendors kind of have restrictions for the kind of information that can be shared between other devices. And because of this, it kind of causes more struggles for people that are trying to have multiple different vendors working in the same area. And like I mentioned earlier, having to do the same development when you're trying to integrate a new vendor into the same operation, because I don't think there's really a standard yet that kind of goes through exactly what information needs to be accessible to devices that are outside of the machine or otherwise in the environment. So being able to operate with PLCs or fire doors or other machines like that. And also, lastly, like kind of these custom interfaces make it also harder for people who get trained on one robot to then go and switch into another one. So the training process also becomes kind of a struggle. But that's all of what I had to present for that.
Great, Prat. Well, thank you very much for that. We really appreciate that. You've really highlighted some things. First, I love the challenges, you outlaying some of the challenges. Obviously, we're working on one small part of that, the AMR interoperability part, but it's great to learn a little bit more and understand your use cases, which I think is helpful. We have a number of AMR vendors on the line today, so I think that was really valuable. Thank you very much.
No problem.
So
Thank you.
Next up, we have Daniel Theobald. Daniel is, along with being the president of MassRobotics and one of the founders, Daniel has a day job of where he is the Chief Innovation Officer for Vecna Robotics, and Vecna supplies AMRs to a number of different customers here. And we're excited to have him. He's going to go into a little bit more detail on kind of just the history of the standard and what we're attempting to do with this first standard. As I said, there's a lot to do here, and we are not saying that this is the end-all, be-all, end-all to standards. It's really just a first attempt and a start, but we think it accomplishes a lot, and Daniel's going to be here to explain some more of that. Daniel, and I'm not sure we have Daniel's video, so you might be stuck with mine or a screen, but Daniel should be on the line.
Thank you, Tom. Can you hear me?
We can. You're all set to go.
Great. Hey, everybody, really appreciate your participation today. This is an exciting event. It's a great milestone for the industry. Really appreciate Prat setting setting the tone here about the need for this. I'm really reminded of some comments the CEO at Intel made many years ago when he said that Moore's law is this principle that the number of integrated circuits or the number of transistors on an integrated circuit would double approximately every 18 months. He said Moore's law is not a physical law. Moore's law was a goal, and Moore's law was a goal that the industry as a whole, the integrated circuit industry, was dedicated to making happen. And he said it was only through pre-competitive collaboration that the industry was able to achieve that goal of essentially keeping pace with Moore's law. And I think that highlights the importance or at least the potential when we work together as an industry to accomplish amazing things and to really move things forward. The future for automation is significant. Humanity needs it. There is a compelling demand for this type of equipment. We're here to allow human beings to get more done than ever before. And that can't really you know, as you roll the clock forward, that can't really be fully accomplished without this idea of interoperability. So we realized this a while ago and determined that there was a real need to get together as an industry and try and address some of these issues. We didn't know what the right approach was in terms of starting out, but we did know that it was important to get a lot of voices involved. So you're going to have the opportunity to hear from some of those voices on the panel today, a representative of a number of different robotics companies that participated extensively in this proposal, sorry, in this standard. But just wanted to point out that a little bit about what the standard, this first version of the standard is and what it isn't. The goal was to provide a first step that allows the industry to move forward in very concrete ways. The goal was to keep it simple so that it was easy to implement, yet provided a tremendous amount of value for end users and for the industry as a whole. And so we decided to have a very narrow scope and be able to address basically status information for the robots. Where is the robot? What is it doing? Some other pieces of information that I'll let the panel go into. It's important to note that this standard is not about safety. While you could make an argument that some of this data could be used to make systems more safe, that is not the intent, and certainly it should not be dependent on for any safety critical applications. It's really just about helping to solve some of the problems that Prat talked about. As you have more and more robots from different vendors trying to work in the same space, they need to be able to communicate. They need to be able to know what the other robots are doing so that they can plan effectively and not end up with, you know, congestion and that type of thing. So today we have members of our working group here to walk us through some of the technical decisions that were made in forming this standard, the data it shares, and insights on its implementation. So first, I'd like the team here, the panel, to introduce themselves. We have Jason Walker from Waypoint Robotics, Chris from Six River Systems, and Zach from Vecna Robotics. Maybe in that order, you can each take a couple minutes and say a little bit about who you are. You certainly introduce the company you work for, and maybe mention why you felt it was important to get involved with this standard.
Yeah, thanks, Daniel. Great intro. I love the connection to Moore's Law. I'm Jason Walker. I'm co-founder and CEO at Waypoint Robotics. We got involved with this standard because we just think it's so important. The industry, the community really is starting to be, if it isn't already, it will very soon be, you know, massively hamstrung by not having interoperability. So getting in front of it, it's really important. We're happy to help.
Thank you, Jason. Chris?
I do not see Chris on the line, so why don't we jump over to Zach?
You're
Zach, you're on
Zach.
I've been unmuted.
There we
go. I'm Zach Dydek. I'm the CTO at Vecna Robotics, and my background is in controls originally, but took kind of a roundabout path, a lot of software development, and now working to make sure that we stay at the forefront of technology in robotics. And I think the AMR interoperability is a big part of that. It's something that my office has been focused on since the beginning of this effort with MassRobotics, and it all stems from just spending time at customer sites and being in the warehouses, seeing the kind of the variety of things that need to be done, and realizing from a humbling kind of standpoint that there's not going to be one company that solves that whole gamut of different activities that go on inside a warehouse. It's going to be specialists in different areas that need to work together to achieve the efficiency gains that we think are possible. So interoperability is one step to achieving that, right? To make everyone be able to work together and do their thing well, but also have efficient handoffs, when things need to move from one vendor to another. So that's why I'm happy to be involved and happy to be here today and talk about it.
Thank you, Zach. I guess we'll see if Chris is able to join us, but let's start out talking a little bit about the data. Let's walk through what data is shared in this standard. So Zach, maybe you can walk us through the data that's shared in the two messages.
Yeah, absolutely. As Daniel mentioned earlier, we tried to intentionally keep the scope fairly narrow. So there are initially just two message types that we send as part of the standard. There's an identity message, which is kind of the registration message that says, hey, I'm here, this is what I am as a robot, this is what I can do. And that kind of registers the robot with the rest of the system. And then there's a status message, which is something that comes at a higher frequency periodically and gives an update on where the robot is, what it's doing, where it's going, that kind of thing. So I'll talk first about the identity message. As I said, it's kind of a less frequent message, maybe when the robot powers up or on request, or if anything changes. Obviously, we would expect to see something come out on this message. And we've broken the message up into kind of shall, should, and may. So again, in an effort to make the standard easy for folks to implement, there's a very small list of absolutely required items that go onto this message. In fact, it's only 6 items that shall be a part of the identity message. And I'll just walk through them quickly, and if there are questions, Daniel or Tom or anyone else can jump in and ask me to clarify a little bit. There's a unique identifier. It's a UUID for the robot. This is who the robot is. According to the system, it's going to be attached to all the messages, but it's in the identity message as well. There's a timestamp, the manufacturer name, the vendor name, so Vecna Robotics or Waypoint Robotics, the robot model, the robot serial number, or some other unique identifier that's used internally, maybe a unique name or something like that. And then there's a robot envelope, basically a bounding box, X, Y, and Z coordinates that specify kind of how big the robot is. And that's it, for the identity, for the shall kind of section. And then there's some additional things that are in the should. These are things that we think are useful and important to share, but not necessarily required to be compliant with the standard. And those are what is the robot's max speed in meters per second? What's the robot's max runtime? How far can it go on one battery charge in hours? Emergency contact information for that robot or for that vendor, the type of charger that it uses, vendor name for support requests, and contact information for support requests. So those are kind of auxiliary information that we think is useful and worth sending as part of this identity message. And then lastly, we have a list of kind of the may category. These are things that are supported by the standard, but vendors might choose to include them or to not include them. A link to product documentation, a thumbnail image, like a visual, which could be used to create like a dashboard with visuals for each robot. The type of cargo that it moves, if it moves cargo, so it could be pallets or cases or eaches or something else. The volume limit and the weight limit for the cargo. And that's it. Those are all the messages that are in the identity. So that's something that you send to register yourself, and you give some information about the robot as you do it, so that the rest of the system and the rest of the robots know who you are and what you do. Shall I move on to the status message? Any thoughts about identity? Okay. So the status message, like I said, more frequent. we have some guidelines about the frequency of these messages, and they're detailed in the standard document itself. But we say minimum of a frequency of 60 seconds or period of 60 seconds, and a maximum rate of 1 hertz, so every 1 second. We would send a status message. So very frequent compared to the identity message. This is the one that is going to give us the current information from that AMR, and that's going to be used by the other robots or by some kind of dashboard or something like that. So it has all the information that you would need to display or to understand what the robot's doing. So first thing is the UUID, the same one that was in the identity message. So you'd be kind of corresponded to that initial registration that you made, another timestamp, and an operational state. This is what the robot's doing. It's one of it's an enum, so it could be idle, navigating, disabled, charging, in manual mode, something like that. There's a full list in the document. The robot's location, and this location is a location within a shared map. And don't know if we'll have time to go into all the details around how shared information for maps is handled in the standard, but you want to tell them where you are, basically.
I was actually going to give Jason an opportunity to talk a little bit about how we do that across vendors. So
yeah,
we'll give him some time to do that in a little bit.
Yeah, so I won't go into a lot of detail on location, but it's just a part of the status. So every time you send a status message, you're sending your location in a way that other robots and other vendors can understand it. Error codes is another part of the status. So if there's any errors that AMR is experiencing, it can send that as like my battery is low, or my emergency stop has been hit. There's an appendix in the standard with all the kind of error codes that are supported. And then there's some should entries for this message as well, things that you should send. The speed in meters per second, the angular velocity, and as well as a list of the future locations that you're going to be going to. So these are places that you plan to be at in the future, along with a time associated with it. So a location and a time kind of as a tuple. And that list might be 15 minutes in the future, maybe like 10 different places that you plan on going. So kind of a sparse list, but that can be useful for example, congestion management, stuff like that. And then some of the kind of mays in this status message are your current battery percentage, your estimated runtime that you have remaining, and trajectory that you're following for the next 10 seconds. So as opposed to the previous one, which is like maybe destinations where you're going to be like at a pick face, different parts of the warehouse. This is more in the next 10 seconds, where is the robot going to drive? So more important for local kind of traffic management. Again, not a safety feature that any of the vendors would be relying on, the results of that message to behave safely. But that message could be used to do something smarter, in those situations. Like what Prat was mentioning about intersections. How do you navigate those intersections? Maybe you can slow down and yield for someone else to go by, but this path for the next 10 seconds gives you some of the information you need to be able to do that. A percentage of the load capacity that you have filled, so how much you're carrying, basically. If you're a pallet truck that carries one pallet, it's going to be 0% or 100%. Empty or full, but another robot with a different sort of cargo might have something in between as well. And that's it. Those are all the things that are in the status message. And again, I just want to emphasize, I've been talking through it a lot, but it's really a very small list. It's something that we worked a lot on to try to just focus in to the things we think actually provide value in the short term, make it easy for vendors to implement this standard and start getting value right away. Over time, we can add to it and make it more complex and more featureful. But that was kind of an intentional effort on our part to keep it simple.
Thank you, Zach. Really appreciate that overview. And Tom, I don't know if we have questions coming in on the chat or anything, but certainly happy to take any questions that are relevant throughout the conversation. So Jason, 3 things. I'm going to give you a multi-part question, challenge you here a little bit. First, Waypoint was the first company to test the standard. You built the interface into your robots. I think you were the first ones to do it. So I want you to share just briefly how long that took you, just as a follow-up on Zach's point. I'd like you to talk a little bit about the location stuff. How do robots from different vendors who all have their own maps, they all have their own ways of reckoning where they are in the world, how do they share where they are in a way that other vendors can understand? And maybe talk a little bit about the GPS standard and how that fits in. And then finally, as you do that, if you can just, sort of give people a sense for how we made these decisions, how the group, worked together to figure this stuff out.
Yeah. So taking them in order, the testing that we did, and I think it's important to emphasize that we put a lot of effort into making this easy to adopt. We wanted to make it lightweight to implement and make it easy for people to do what they could and then do more when they learn more. And so our implementation of it as part of the testing process to see if we could keep it easy, it was relatively easy for folks who are familiar with ROS, and most things in robotics, if they aren't actually ROS, are very similar to ROS. Most folks are going to find it pretty quick, pretty easy to implement this standard. The folks who are used to doing development with web-based activities and have some amount of robotics knowledge, mostly around language, I would say, I think it's going to be pretty easy for them to implement it. And so for us, given the architecture that we have a ROS native robot. We use a WebSocket interface for talking to external systems. And so that made it a really natural fit. And indeed, many robotics companies have those types of interfaces to their systems. So it'll be familiar and it'll be easy and relatively speaking. And that was very deliberate. We as a group, again, wanted to make it as effortless as possible to implement it. And Waypoint has always taken an approach of having individual robots being as autonomous as possible, but also being as open as possible. To we had a feeling that interoperability was going to be a big deal because we love our robots, but they don't have forks, we love Vecna robots too, but they can't slide sideways and drive through tiny doorways. So there's the state of the art in robotics is such that you have to have a lot of different form factors to solve all the problems, and it'll be that way for a while. So there's not going to be any winner to pick. You're going to have to pick a bunch of winners, and the sooner we can all play together nicely, the better that will be for everyone. So, we built it that way, but it'll be I think easy for folks to adopt it. In terms of the location methodology, we took the approach that I don't know, this might be a very limited analogy, but sometimes if you go out hiking, you can find these placards that are put there by the U.S. Geology Service, and or surveyors in towns have these markers that they put out there. And so we took a similar approach. If we have common points where all of the vendors identify those locations that are physically in the building relative to their map, then each vendor can have those locations kind of be the anchors that you use to do the coordinate transform between all vendors. And so as a method of visualization, this is something you could literally do or something to help you visualize it. But if you taped a big box on the floor, you know, in open space at one part of the building and another part of the building, and said these are going to be my anchors, then each type of robot could identify those boxes within their own map and be able to establish a coordinate transform to be able to share their relative location. And then each receiving system would be able to make sense of it based on their own map coordinates. And so that's the thing that enables, you know, the many maps to still be able to make sense of, you know, where is a robot in its own map relative to where the others are. The GPS reference that Daniel made, this standard that I just described kind of already exists. It's very similar to the way we do GPS. And Zach, please jump in if I don't say this quite right, but we wanted to establish the message in a familiar form, and one that would make sense for people who are used to locating things in a shared coordinate system, which is what GPS basically is, and that will lend itself in the future to robots that are indoors, outdoors, indoors and outdoors, all being able to adopt the standard over time and utilize it. And then, you know, how we decided things, it was a great process. You know, people would, so first of all, we had customers in the loop, and FedEx was a group that was very gracious with their input, and you know, P&G, Prat, as he you know, gave in that opening statement. Each of the robot companies brought their voice of the customer into the mix, and then we had actual customers keeping us, you know, on the reality side of geeking out, and just really kept it focused on what's actually useful. And we also had folks who have done interoperability projects. The folks from Open Source Software Foundation, the Ross folks, working on a cool project in Singapore where they're trying to solve this problem for a while and making a lot of good progress. So we really gathered as much information as we could, and we tried to distill that information into, you know, what's the most useful, easiest to implement, and had a rapid iterative process. One of the things that I just praise MassRobotics enough for is keeping the group engaged, gathering a great quorum of people, and getting this done quickly. The safety standard we've all been kind of waiting on for, I don't know, 5 years at this point, and it just came out this year. And by comparison, this was developed very quickly, and with, I think, a great consensus of input from a lot of different companies who are simultaneously collaborative and competitive in different situations. So it was a wonderful community exercise.
Thank you, Jason. And I think it goes without saying that we're just getting started. As Tom mentioned, this is just the first step. Let's talk a little bit about the methods of messaging. You know, sort of, we've talked about the data. Well, how does the data get where it needs to be? What protocols are we using and that type of thing? And I'll just throw that out there for both you and Zach, and you can tag team that.
Yeah, I can start on that. I think Jason alluded to it earlier that that there are some very common interfaces that we see a lot in robotics vendors and WebSockets for external communication is definitely one of those ones that we see a lot of. We considered a number of different interfaces before actually deciding to go with WebSockets. We looked at, purely ROS, basic Prod, ROS1 and ROS2, like OpenDDS standard for ROS2. We looked at RabbitMQ and some others, and eventually, again, keeping with the theme of making it simple and easy to implement, we wanted to build it on top of an approach, a protocol that is mature and well understood, and something that every vendor would be able to implement quickly and easily. And that's how we came to WebSockets as the approach. So in the MassRobotics GitHub, which I don't know if there's a link in the handouts or somewhere, people can go there and you can see what those message types look like. We have a schema and a JSON file that just tells you what you need to send over the WebSocket, and we have some example implementations of a client and a server that both speak WebSocket, so they'll open up a WebSocket connection between one another and pass the information back and forth. And you can implement your own client on your own robot. I did that in an afternoon. It was fun, and the robot can send that information up to the server and just display it. So it's very simple. And yeah, again, using WebSockets as the technology.
I just want to jump in here for a sec because Zach mentioned it. There's, for those of you who are watching, there is a tab on the right-hand side. If you open that up, you'll see handouts. There are 4 handouts attached. So there's further information. We're going to get some great presentations coming up from other efforts and other parties involved in standards, and they've got some of their handouts there as well. So feel free to download those by just clicking on that tab. But thanks.
I would definitely encourage folks who are interested to take a look at the GitHub, especially. And it's a place where you can see all the information that we've talked about so far and a whole lot more in terms of the standard document, which describes everything in detail, as well as those example implementations and code. You can go look at a place where you can give feedback, submit pull requests. We had some pull requests from the community to improve things. So definitely encourage people to look at that resource.
Yeah, and Zach, correct me if I'm wrong, but I think there's also an application there that folks can use as a test target, right? If they want to.
Exactly. Yeah. The server implementation is there. It's a node application that you can just run on a Linux system, and then hit it with the WebSocket message, and it'll tell you, no, you did it wrong. You're missing this required field, or yes, it's good, it's valid, and you did it correctly. So that's a useful little utility if there are any people from robotics vendors who want to try to implement the standard to be able to use that.
Thank you. And Tom, I was hoping that you could maybe just share a little bit about the MassRobotics Interoperability Compliance Badge, and maybe also how other people can get involved, whether you're a programmer who's building robots, or an end user, or an integrator. How do people get involved very concretely?
Yeah, Daniel, thanks for that. So first, we are really excited about all the support that the folks who are on the working group today have provided, getting us this far. And as I mentioned, we're looking to continue to develop, and we are excited to have later today some folks who are doing other efforts explain about what else is going on, because there are a lot of things happening in this space. But if you want to get more involved, particularly in the MassRobotics one, if you go to our website, which is www.massrobotics.org. There's an AMR interoperability tab. If you go there, there's more information, the links as Zach pointed out, but there's also a form that you can fill out that allows you to get information on the standard and also provide feedback. And Joyce and her efficiency popped that right up. Yeah, you can, this slide is in the handouts, but we encourage you to go look at the standard and then provide feedback. We know that this is a first effort. There's probably things we haven't done or we might have not done the most efficiently, and we'd love to hear back and learn more about it. So yeah, we encourage everybody to get involved.
Great, and let me just give some kudos real quick, and then I'll turn it back over to you, Tom. So people, some of the companies who are involved with the publication of the standard, and again, just to emphasize, numerous hours were put in by all of these. Vecna Robotics, Six River Systems, Waypoint Robotics, Locust Robotics, Seagrid, Mir, AutoGuide, Third Wave, A3, and Open Robotics. Additionally, all the end users from major shipping and distribution centers, just a tremendous effort. I really appreciate everybody's contributions to this, and I think that it will help us as an industry to move forward and better meet the needs of our customers. So thank you, everyone. Tom, back to you.
Great, thank you, Daniel, appreciate that. So one of the things that's critical, obviously, is the use of the standard. We can work and develop it, but if nobody actually implements it, then that shows that there's not an interest. And we already have had a number of companies reach out and start to do this work. Companies that were not involved directly in the working group, but are interested in what's happening. And I'm really excited to have Julian Cerruti with a brand new company to us, but has been around for InOrbit, join us, and he's done some work with the standard, and so he's going to have a presentation on that. Julian, thank you very much for joining us, and I'm going to turn it over to you. All right, and your slides are up. There you go.
And audio is up too.
Audio is up too. So we're good, 2 for 2.
It takes some juggling to get everything up. Well, first of all, thank you very much for the opportunity to be here, and also for all this great work that he's been doing. As you just said, we are a little bit, we're just joining the effort right now, but we're very excited about this. I'm a co-founder and CTO at InOrbit, and today we're going to show how we've been starting using the standard. But first of all, there is a really small joke that I really need to tell because it only works in this audience. What did the idle AMR tell to the busy cobot arm? The answer is, for the most part, we don't know, and this is why we're working on interoperability, right? All right. First, I'm going to go fairly quickly over stuff because I have a lot of things to share, but I'm happy to take questions or go to details later or offline at any time. First, for a bit of context about, like you said, the InOrbit's a little bit new to the team here. What we do, we have the goal, just like the same team here, to accelerate the adoption for robotics. I really liked Daniel's introduction on why this is all important. We share the same vision. We focus specifically on common and differentiated infrastructure and not on the robots themselves. We are trying to help robotics companies and adopters focus on what they do really well. That's really what we do. And we've been around for a while. We've been working with several dozen robotics companies, and we've been helping them operate and pretty large fleets of several hundred robots in 24/7 operation. Our main product right now, it's a vendor-neutral robots platform that allows connecting heterogeneous fleets of robots. It's specifically focused on doing a secure and efficient connection between the robots and operators, local and remote, engineers to do analysis, and executives and line of business applications. And the most typical uses are to be able to reduce time to resolution and also to understand behavior to improve over time. with the standard, like of course, we came into it only relatively recently, and we've done two different things that I want to share today. One is extending our robots platform to support and allow easy connection of compliant AMRs. And also, we've done a little bit of experimentation and participating in here, trying to make it even easier, if that is even possible, to adopt, and also to try to contribute any comment or addition that we had. For the first part, what we did is we implemented on our robots platform, we added a sort of a proxy element that implements the compliant protocol that has been published. It was very well documented, very easy to use. Thank you very much. And through this, now the platform basically, from the point of view of the standard, acts as a receiver. That allows any existing InOrbit user or new ones to basically just enable compatibility. They get a unique receiver URL, which they can configure on the AMR using the standard, and boom, then they get already the connection to the system. With that, I think what is interesting and rewarding is that by implementing the standard, and it is already possible to connect to a platform such as InOrbit and get a lot of functionality right out of the box immediately, including real-time monitoring of like isolated robots or a fleet of heterogeneous different robots, being able to use the status report for notifications and even integrate this notification in third-party systems, being able to do fleet-level tracking of events that occur, and even get longitudinal information for analysis from logs, graphs, timelines, and even you can look at all that information on a time capsule for a particular mission or incident that occurred. And that all comes like out of the box very easily thanks to the standard. On the other side of things, what we did is we are like it sounds like many people here, we are well acquainted with the ROS community. So we thought, what if we help advance this by creating some additional open source components to make it easier? So what we did is we developed an open source package. It's basically a ROS component that allows connecting any ROS robot and make it convert it into a compliant AMR sender through a configuration file only. It's very easy to use. You just need to, like any other ROS package, include it as a dependency, get the information from the mapping with all the details that that Zach mentioned recently, and that can be all configured through a mapping file. We used typical infrastructure as code standards, and it allows mapping from environment variables or from coordinate frames from the local ROS system, or even mapping from different messages to concrete report status. This is of course open, available, and I think the handout is available too, so any distribution hopefully will make it even easier to have the standard up and running for existing robots. And just to close, I wanted to share a little bit about our experience coming in here. And I would say, after working with many dozen AMR developers and doing a lot of work with various proprietary approaches of different sorts, and also being somewhat involved in other initiatives, I would say that the balance is super, super positive. Maybe trying to focus a little bit on the most the most obvious positive things are things that I already heard mentioned several times, so clearly it was intentional, it's not an accident. But I think the pragmatic approach and simple, just deciding something quick and get it out and going very quickly, it's really great. It definitely sets apart from other standard initiatives. I would say that the community of people of leader companies and names present here that we'll be able to gather definitely gives a lot of credibility and makes it very appealing to participate in the standard. So I think that's great. And the visibility that the group has been able to generate through this has been really differentiating and very good. Perhaps in terms of what are maybe our humble opinion of where are the opportunities to continue having more impact the fastest, maybe the first two things are, I think, have already been mentioned. Of course, adoption. The faster we have more compliant AMRs in the market, I would say it's an exponential how quickly this all will come into more of a reality. And of course, this is just the first step. There are many other use cases, functionality, growth in maturity in a lot of directions. As we grow, I'm sure we'll be able to tackle them. Perhaps the only other thing that I will bring up that I didn't hear before, and maybe it's a benefit of being a little bit relatively new to the MassRobotics community, is I would try to continue always working on the perception of the standard and the group on the rest of the broader robotics industry. There are coming from other communities, I don't know, maybe more in Europe or West Coast centered or other areas that are not as familiar with MassRobotics. I would say sometimes the very good virtues, the things that are listed on the left column, like being very pragmatic, going out there, getting things done quickly, might feel a little bit intimidating, and people may not feel sure about how to participate, how to contribute, and how to adopt this too. So I would say the biggest risk of all would be that the initiative ends up being appreciated as a more commercial effort and not so much as a really dearly needed technical contribution, which it really is. So I think we need to continue working on that. And by the way, this webinar, this exercise, like all this invitation, all the companies that are putting together, the participation and initiatives are great examples of that, and we should do more. That's all I had. Thank you very much.
Yeah, Julian, thank you for that. And I really appreciate the feedback, especially on the opportunity side. You highlighted security, obviously a big thing that we haven't even addressed here, which I think is a growing concern within the robotics community. Sensor data is another one that you raised. You know, we don't really have an avenue for making that data public, so that's something to think about. So a lot of good things that you raised. Thank you very much. We appreciate you starting to work with the standard. It's always great to hear that as well. So as I mentioned earlier on, we're not the only organization that's working on standards. There's a number of different organizations that are doing different efforts, and we're now going to hear from a couple of them. Next up is Cara Mazzarini. I always butcher that name. She is the technical portfolio manager for the ARM Institute out in Pittsburgh. And we've partnered with the ARM Institute on a number of efforts, but they have some really cool work that they're doing. And I wanted to give Cara a chance to share some of that. So Cara, thanks for joining us. Appreciate you being here. And I'll let you share your presentation. Oh, you're muted. Hang on. Joyce will have to unmute you, or if you can unmute you.
Okay, can you hear me now?
There we go.
All right, wonderful. And can you see my screen?
Yep.
Okay, great. First of all, thank you to Tom and Joyce for having me here today. It's always a pleasure to work with MassRobotics. First, I'll tell you guys a little bit about ARM Institute, and then also a bit about the interoperability projects we've been working on over the past few years.
So, Cara, I have to say before you get started, the screen I see is your main screen with a lot of files. So I don't see the presentation.
We can fix that.
There you go. I don't know if you want to go into full screen mode. There you go. Perfect. Thank you. You're all set.
All right, no problem. So again, ARM Institute, we're a national consortium focused on strengthening U.S. manufacturing. We've been around since 2017, and we are located in Pittsburgh. But we do a lot of work in the Boston and Massachusetts area in general. I've had the pleasure of visiting the MassRobotics facility a couple of years ago, and so we're really happy to work with you guys. So ARM is focused on accelerating the development and adoption of robotic technologies, specifically for manufacturing applications. And that's one of the reasons why interoperability is so important to us. We're looking at technologies that really have the potential to scale and change the industry, make robotic solutions and automation solutions more accessible to those who need them. A big part of our mission is our ecosystem. So I mentioned we work a lot in the Massachusetts area, but we have members all across the United States. Our member types vary from universities, big companies, startups, nonprofit organizations. And so we take a lot of pride in having a consortium full of innovators and people of different experiences as well. So these are our 5 top technology strategic focus areas. You can see these are not in any specific order. So there are 5 weighted equally, and interoperability is one of those 5. What that means is that we are always looking for innovation in this area. Every time we do a project call, which we do several times a year for several $1 million, we put out calls for proposals highlighting these specific areas. So we're looking for our members and other innovators to come to us with ideas for how, as an industry, we can leverage interoperability technology solutions to improve manufacturing and ultimately make the US manufacturing base more competitive worldwide. So we have funded to date over 80 projects. I'm obviously here representing our technology team, but we've also funded many education and workforce development projects as well. All of our projects are tied to our technology focus areas, but as you can see from some of these examples, they also have a use case or an end goal. The objective of the way we've structured this technology focus and use case focus is the idea that the technologies, even though it may be applied to sewing, for example, that same technology interoperability, as the example we're talking about today, has the ability to be applied across many different manufacturing applications. So I wanted to highlight 2 of our interoperability projects that have happened in the last couple of years. Both of these were led by Siemens, who is a very active and strong supporting member at ARM, but they were collaborations with several of our other members as well. So the first project, the Seamless Multi-Robot, Multi-Machine Interoperability, focused on what would it look like for our robotic systems to be able to talk to our industrial machines. So it was really focused on enabling that Industry 4.0 for much broader communication between a variety of different system types and communication languages. That same project was then demonstrated at Schlumberger, and who was a contributing team member at the time, ultimately rolled into that same core technology module, was rolled into the next project, the interoperability and orchestration of autonomous mobile robots. So this project, in which Vecna and Waypoint Robotics are both contributing members, we're pushing further the idea, okay, well, let's put aside the industrial machines. We've seen that in the last project. Let's talk robot to robot. How can we enable a fleet of a variety of different robotic systems, each that are, like the previous panelist mentioned, precisely chosen because they're good at doing a certain task or a certain function within the system of the process overall? How can we help them work together, and how can a plant manager as easily as possible integrate all of those systems and manage them day to day? So looking into the future, we always have more opportunities for projects. We have a project call that just closed, 2102. The first numbers always represent the year that we are in. So we've received several projects. I can't say anything about that yet, but 35 proposals, and we are in the throes of reviewing them, hoping to see some more interoperability concepts within that group. But I want to encourage you all to follow along, because we'll have more technology project calls this year and in the future. And these are opportunities to come to us with new ideas and new ways of solving this problem. This is just in closing. If anyone's interested in learning more about ARM or our projects, we'd love to talk to you guys about that. We'd love to have any of these innovators as members to the Institute. So please don't hesitate to contact me directly, or you could reach out to us via membership@arminstitute.org. And that's the end of my presentation.
Great, thank you, Cara. So as Cara mentioned, ARM funds a lot of projects across a great many different areas. We're excited, of course, the ones that relate to what we're working on here on the interoperability standard is one of the ones that she mentioned that they funded, and that we'll be using this standard to test coming up later in the year. So down at a FedEx facility in Memphis, they'll be using a number of different platforms. Cara mentioned some. I think FedEx has some others, so I don't want to speak for FedEx, but they will be implementing, some of these manufacturers will be using the standard and sharing the data in one of these implementation tests. So we're looking forward to hearing about results for that, and we'll always stay tuned to the neat new projects that ARM is introducing. And yeah, definitely look at those project calls, because there's always something interesting in those. So Cara, thank you very much.
Thank you.
Great, and now we're going to move on to Chris. So obviously a lot of folks have talked about ROS. You've heard a number of people reference it and mention it. We're really lucky to have Chris with us. Chris joins us from Open Robotics. Sorry, I'm going to do that. And Chris is going to talk a little bit about some of the efforts that they're doing as well. So Chris, thank you very much for joining us, and take it away.
Thanks for having me, Tom. You can see my
I can, yep.
Okay, let me show my presentation. Let's just make sure you can see the presentation.
Oh, and you have videos. I like that already.
Well, they're moving just. Oh, no,
we show robots. We should have more videos. Everybody, it's good to have videos.
All right, you can see my presentation?
Yes, yep.
Fantastic, thank you. So yes, hello everyone. My name is Chris Lalancette. I'm here from Open Robotics. We used to be the Open Source Robotics Foundation, but we've now rebranded to Open Robotics. So what I'm going to talk to you a little bit, just for a few minutes here, is something very adjacent to AMR, and actually I'll show you something related to AMR at the end. So, right, we're responsible, Open Robotics is responsible for ROS, ROS2. We also, the other big thing we do is simulation, of course, with Gazebo and Ignition. But what I'm going to talk to you today is about RMF, which is a project we've been doing in Singapore for the last like 3 years. So what RMF is trying to do here is, you can go out and you can buy fleets of robots that do things today, right? So deliveries, cleaning robots in a hospital, security patrol, all these sorts of things. And these fleets typically come with managers. The problem with this is that these fleets often assume that they're the only robots that are in whatever space that they're in. So one like common solution that they have is that they'll stop and ask an obstacle to move aside. Now this only works if the obstacle understands what they're talking about, and of course if it's another robot that's trying to share the space, they're going to be stuck with each other, particularly in very tight areas. So one solution to this could be to modify the vendor's fleet manager software to basically interoperate, but vendors are reluctant to do that for two major reasons. One is that they may just not want to enable competitors. But a bigger major reason is that if these robots are already deployed in a hospital or at a facility, it's often the case that they do not want to go in and make changes to something that already works. So with that in mind, what RMF is doing is RMF sits above the existing fleet managers and looks at the whole picture, looks at all of the fleets together. So it doesn't directly control robots, but what it does do is it tries to observe and predict the robot traffic, and then it sends requests to each of those managers to try to prevent those conflicts or fix them if they occur. So, and one other thing, of course, is that us being Open Robotics, we want this all to be open source. So we want this to push forward the state of the art and be able to have facilities, trust that they'll be able to do these things. So everything I'm talking about here is open source at this github.com/openrmf organization. One thing is that, how much control does RMF need over these fleets? So we split it into 4 levels. First of all, if there's no fleet API and we can't talk to the fleet manager, there's obviously nothing we can do, right? We can't get any information from the robots. We can't send things to the robots. It's not interesting. So we just don't consider it further. One level up from that is where we get read-only data from the fleet manager, so that the fleet manager is providing some API so we can get information about where robots are located, where they're going, sometimes even the waypoints in between. And with that, we can do things in RMF like make other robots that we have more control over avoid these read-only robots, or at the very least be able to predict in the future where these are going to be and try to not schedule other robots to even start until these pathways are clear. But that doesn't give us that much control. So the next level of control is traffic light, where a fleet manager gives us information, but also allows us to do things like pause a mission. And if we can at least pause a mission, then we can avoid a lot of conflicts and places where competing robots will get stuck. And then, of course, the highest level of control is where we can have a lot of control over the robots, their paths they're going to take, their waypoints, that sort of thing. And with that, of course, we can then do things like just make robots take different paths, equivalent paths, or even temporarily move out of the way of another robot. So in RMF, we have examples of all 3 of these levels implemented. So we know that this system at least works in some sense. As lots of people have talked about, of course, we're Open Robotics, and a lot of what we do is ROS. So one big question here is, how does ROS interoperate with RMF? And so RMF is built on ROS 2. All the internal components of RMF are using ROS 2, and RMF is available. Most of these packages are available in ROS 2 Galactic, which is our latest release. We're not quite there, but we're on our way to getting most of that released. That said, if you want to do multi-robot systems using ROS, RMF is not the only way. That just happens to be the way we're doing it now. And it's if you want to make a multi-robot system by having ROS talk directly or using other protocols, that's how other people are doing it. So that's just something to keep in mind as well. And then finally, those who are familiar with ROS 2 know that ROS 2 uses DDS as its communication mechanism. RMF chose not to use DDS all the way to the edge, and there's 2 main reasons for that. One is that DDS has some scaling issues, particularly when it traverses very wireless or intermittent networks. The other big reason is that of course, RMF at the end of the day has to talk to these vendor fleet managers, and those have whatever proprietary APIs and protocols that they're using. So, or even not necessarily proprietary, but just their own protocols. And so RMF has to be able to talk all the way down to the edge there. So we're only using DDS on sort of the middle part of RMF, and then the rest of it are these connectors that connect into the fleet APIs. And the next 3 slides are just some of the capabilities. So this one, it shows basically a bunch of robots from different fleets scheduling. And on the left side, as a robot is going down and there's no conflicts or there's no predicted conflicts from RMF, that path is green. If there is a predictive conflict, then the path turns red. And it just shows RMF will replan for these so that they can accomplish their goal without collisions. Another thing that RMF contains are tasks. So you can give tasks to RMF as opposed to the individual fleets, and then RMF will do things like choose the appropriate fleet, choose the fleet that is the most unloaded or that has the robots in the best spot, and also choose a fleet where there won't be as many conflicts. And then another thing that RMF can do here is to control doors and lifts, so that these doors and lifts can be shared by different by robots, which is actually shockingly a very difficult problem currently without RMF. And then the last thing I want to just mention here before I run out of time is we've recently done some prototype work of having RMF talk to the MassRobotics AMR interrupt server. So what we did here is we took RMF and then we made it so that RMF could deliver goals to a MassRobotics AMR interrupt server. We also could do the other way around, where we're getting the information that Jason and everybody else was talking about earlier, but we haven't implemented that yet in this prototype. But the next thing here just shows what we're doing. So we have a task submission, as I just showed, that RMF can do. We submit a task to this robot that's on the right-hand side, and that robot is running an AMR interrupt server. And you can see in the simulation, the robot has started its task. And then on the left side, the tab will switch in a second here. Yeah, and that just shows that this is the JSON message. If anybody who's looked at AMR in any detail, those are the JSON messages that AMR is, and so that's what we sent down to the robot to start its thing. So that's it. It was a very quick overview. There's obviously a lot of details in RMF, but I just wanted to give a quick view of what we're doing and how that is related to everything going on with the AMR. So if you have any questions about these, the documentation is all here. I sent these slides so that they can be disseminated. So if you have questions, please feel free to contact us on these GitHub projects, and we hope to see contributions from the community.
Great, Chris. Thank you very much. Obviously, we appreciate what you're doing on ROS, and ROS continues to be an amazing tool for so many companies and developing and moving the industry forward. So, and obviously, thank you for what you're doing on the RMF as well. Now, we talked about what the standard that we've worked on at MassRobotics. There are so many things that we didn't even touch on. And one of the great organizations that is looking at different things is A3. And some of you might know it as RIA, but they're now called A3. And we're really lucky to have Robert join us today, who is going to talk to you about some of the other efforts, both that AMR does. So you heard a lot of our guys mention, this is not, our interoperability is not a safety standard. There are some great safety standards there. You need to implement those. A3 has been really involved in those, but they're also doing some other work. So Robert, great to have you here, and look forward to your presentation. No, I can't hear you. All right, hang on for a sec.
Perfect. There we go.
There we go. Now
Tom,
we go.
thank you so much for having me. Let me make sure I'm showing you the right screen, which I'm not. I've done about 8 million of these this year. You think I would know how to show my correct screen at this point. There we go. All right. Give it just a sec. There we go. Perfect. So I got 5 minutes, and I told somebody I had 5 minutes, and they said, Robert, you can't say your name in 5 minutes, but I'll try to. I'll try to get through all this as quickly as I can. As Tom mentioned, I'm Robert Huschka. I'm the Vice President of Education Strategies at the Association for Advancing Automation. As he said, you probably know us better by one of our daughter associations, specifically in this case, the Robotics Industries Association. But earlier this year, we made the decision to become a single association for advancing automation. All the associations you see at the top of the screen turned into A3. We represent almost 1,000 companies, or more than 1,000 companies in the robotics, vision and imaging, motion control and motors, artificial intelligence, and advanced automation spaces. You can check out all the information you want to see about us at automate.org. I hope you'll check it out. Now, Tom mentioned our work in safety, which is obviously a critical part of industrial robotics. Jason from Waypoint also mentioned that late last year we released R1508 Part 1, which is the American National Standard for Industrial Mobile Robot Safety. Now, Part 1 doesn't touch at all on interoperability. It mostly deals with the requirements of robot manufacturers as it relates to safety. But as we move into part 2 and ultimately part 3, it'll be a 3-part standard. We're going to talk about integration, implementation, keeping robot systems safe, and there obviously interoperability will play a more important role in how we keep our work environments safe. So you can find out more about the R1508 standard on our website. You can even purchase it there. But more importantly, I want to say, if you want to become involved in the creation of the standard, we're moving, and Jason noted earlier how long standards making can take. We're moving at a much quicker pace on R1508 part 2. So if you're interested in participating at all, please reach out to us. I'll have some more information on how you can reach us later. But in addition to that, we've tried to pull back up as the global voice of the robotics industry, pull back up to 10,000 feet and take a look at the current landscape of the interoperability efforts going on. Tom alluded to this earlier, that MassRobotics is is one of the many efforts that's currently going on around interoperability. Our goal is not to get in the way of any of those efforts. I think a lot of people are doing a lot of great work in this, but we also wanted to just make sure we took stock of all of them. And then our goal is to put a report together with our key findings back to the A3 Standards Development Committee to discuss next steps. But really, as an association and as the standards making body for the United States related to robotics, we just want to, and this will age me a little bit, make sure we don't encounter a VHS Betamax situation where there's a ton of competing standards out there in the field. Maybe that's not even a bad thing, but we just want to sort of keep an eye on everything and certainly share those findings out with the whole community. Beyond fleet management, we're looking at several potential areas of discussion. Some have already been touched on here: robot-to-robot communication, data standardization from robot to server or to cloud, and also battery charging infrastructure, which has already been mentioned a little bit during this webinar today. But again, our goal now is to landscape these efforts. So if you're aware of any efforts that are out there, especially ones that weren't touched on in this webinar today, please reach out to us and let us know so we can just begin to take stock of the ecosystem. As I mentioned, if you're interested in participating in any of our efforts, either the Interoperability Task Force or our standards making, my contact information is there on the screen. You can also reach out to me on LinkedIn. We'd be happy to hear from you and involve you in our efforts. Also, though, Tom mentioned the interoperability test between MassRobotics, the MassRobotics protocol, and the ARM Institute that's coming up later this year in the FedEx facility in Memphis. We're hoping that will align with our Autonomous Mobile Robot Conference, which is October 12th through 14th. I talked to FedEx yesterday, and all is looking good at this point. They were so excited, in fact, that during this call even, they sent me this photo of a robot in Memphis. So we would love for all of you to join us down there, both for the conference, but also potentially for the interoperability test. And if you're interested in AMR safety and broadly robotic safety, everybody is, we have an International Robot Safety Conference coming up. This is a virtual event, September 20th through the 22nd. We would love for you to join us. But broadly, if you have any questions about any of that or any interest in the activities of what was formerly RIA, but is now the Association for Advancing Automation, please reach out to me. I'd love to hear from you. And I think that was under 5 minutes, but I wouldn't bet my life on it.
Great, thank you. First, thanks for keeping the time. You did a great job there. Appreciate that. We sometimes have discussions that go a lot longer, so I know keeping you to 5 minutes was good. Thank you for doing that. And you talked about questions on this and others, and I know we've gotten a bunch of questions in, and we have not tackled them, and I apologize for that. We've got one more speaker who I think is going to be you'll find fascinating, so I want to make sure we get to Bern. I saw your questions on like control messages and other things. We'll get to, if we don't get to them, we probably won't get to them today. We'll make sure that we have someone address them and get answers out to you. So we've been talking about interoperability standards primarily targeted at within factories and warehouses. But as we know, there's a whole world outside, and there's a lot of AMRs that are moving outside on sidewalks in different areas, doing different things like delivery. And the same challenges that we face indoors are going to be faced outdoors. but with even further challenges, because much more of that environment is going to be shared with people and other vehicles. And how does that happen? And you just can't have tons of these on limited sidewalks. You've got to manage all that. Well, I met Bern probably a couple of months ago now, and he talked about his neat efforts, and I thought this would be a great opportunity for him to share a little bit about what they're doing. It's not directly standards like what we've been talking about, but I think you'll find it very interesting and very applicable. So Bern, Bern, I know it's going to be challenged to keep it to a short period of time, but we'll let you go at it, Bern. Thank you for joining us, and take it away.
Thank you. Can you hear?
Yes, and I can see your slides.
All right, good stuff. That's all I can see is my slides. So I'm sure everyone's read these by now. I am going to take you outside. Let's go out for a walk. Let's get out of the factory, off the floor. Let's get out to where there's pedestrians, where there's people walking their dogs, where there's small children. Let's go out where robots are going to be challenged in quite a different way. And I'm going to be talking about systems above the level that we're talking about now. I'm assuming, for better or for worse, I'm assuming that these robots that are out here on the sidewalk doing many things. They may be sweeping or surveilling or cleaning. This one on the bottom right is checking license plates for overdue parking and so on. So all of these kinds of robots are out competing with space, with humans, other machines, and so on. One thing is right now, the current state of sidewalk robots or pathway robots is that they're telemonitored and teleoperated. So in this case, one person may be watching 1 or 2 or maybe 3. We'd like to get to a point where one person can watch 20 or 30 of them and just tuck in when it's required and so forth, but that's a little bit in the future. But so this standard that I'm going to be talking about is for this world of the robots that I've been showing you. So the problem is, again, it's multi-vendor like your problem, variable purpose like your problem, even more purposes. I just showed you some examples of it. They all have independent schedules. The vendor that has a problem of moving snow is independent of the vendor that has the problem of moving a package. So that, and even the ones moving packages like FedEx and UPS, they just have independent schedules. They're going about their business. How will the traffic control work in these circumstances? How should the robots behave? Should they stay back and be shy at the intersection? Should they line up? And of course, in this silly case, would be blocking pedestrian traffic. Should they just cluster around and do their best and could be congested, or should they be I guess or should they be competitive in some way? There's a lot of noise coming from somewhere.
Yeah, sorry, that's from my side. I'll apologize.
Okay. So right now, I mean, the history of robots until now, and you guys understand, you're in the middle circle now with the multi-vendor problem in the factory warehouse, the mining, the farming, and so forth. You guys are completely understanding of that problem. We're going to now move out into shared public spaces. I mentioned already non-involved humans. Non-involved human is a human that's out there in that space, got nothing to do with it's not trained to work with the robots. It doesn't care about, it's not collaborating with the robots as you might be in a warehouse or a factory. These are just other people doing other things, completely uninvolved. And also, we're being mixed with automated and non-automated vehicles as well, in the case of robotaxis, for instance, and so forth. So we're moving into a sort of kind of an international standard. I'm going to talk to you about an ISO standard, international standard. And this traffic is actually going to somehow be influenced by or managed by or somehow controlled or governed by public authorities in some way. They may even be entering the issue of pricing. So they may be pricing the use of the sidewalk, for example. The standard itself, all the kinds of things that you've already been talking about, the data, the procedures, the protocol, and so forth. I have to deal with all levels of automation, whether the vehicle is fully teleoperated, partially teleoperated, or really kind of a level 3 or level 4 automation and so forth. The standard has to cope with all of that. It has to cope with machines on the sidewalk, on the pathway, or in the roadway. And this, again, a robotaxi is a robot, of course, in the road for passengers and so forth. I want you to think about what we just heard from Chris. I just added this line now when Chris talked about RMF. We're up at that level, except that the operator is, or the governor of this would be at the regional or municipal level not just at the factory floor level, for instance. There's 11 parts planned so far. I was in a conversation today in which another part probably needs to be added. Where you see the S, it means it applies to the sidewalk. Where you see a K, it applies to the curb side. In other words, the parking side, the robotaxi side of the curb. And so with its only S, it only applies on the sidewalk. And if it's only K, it only applies at the curb side. Otherwise, if you see both letters, it applies to both, because there will be cases where robots might be loaded into a truck. That truck parks somewhere. The robots are let out of that vehicle to do the delivery. So this is the kind of thing that a FedEx or a UPS might do in the future. They might bring 3 or 4 robots to a location, park the vehicle, and those robots would do its job and so forth. So obviously, there's a common data dictionary. I'm not going to go into what this data are. This data is, kind of in a 90% level of understanding what all this data is. Just listening today, I think there's a couple of things that I missed that should probably be added to this. So I've been on a learning experience this morning or this afternoon. But on the right, this is all new. I'm just beginning this part where all the procedures for reserving or for queuing. The queuing means that there's a reserved space for a robotaxi to let a passenger off, but now there's another robotaxi coming along in a few minutes. In a sense, it's waiting for that space. What happens if that vehicle arrives but that space isn't vacated? What does the vehicle go around the block as we do now, or does it stop and let its passenger off in the bicycle lane? What are the rules when you're waiting for that space, or if the space is not available? How do you handle all those exceptions and so forth? So just to cut this short, I'm working now with the representatives of 11 different cities. Some of these are in Europe, some of these are in the States, a couple are in Canada, like Orlando and Pittsburgh and Washington, D.C., Boston are included. Lisbon and Budapest and London, England are included, and so on. Budapest, of course, is not in London, as you all know. I didn't say that very well. I'm looking to work with a dozen vendors. I am working with 7 now. And I put a call out here. I have no logistics vendor, no logistics operators, a very, very critical missing element of this. If anybody knows any logistics operator that, exactly what I'm thinking of, some of you may be on the call, I'd like to talk to you. We meet 3 times a year in a virtual roundtable, look at the work that's done, criticize that work. I do welcome observers who are not sponsors, but you're welcome to join and watch and contribute externally as well. So that's it. Thank you. That's my company, Harmonizability in the Center. I'm doing this work under the aegis of ISO, and I'm thanking MassRobotics very, very much for the privilege of talking here this morning. I don't know if there's time for any questions. I think there is not, but thank you very much.
Ern, thank you, and appreciate you coming on and sharing a little bit about what you're doing. It's truly fascinating just to think in the future of the volume of robots that could potentially be on the sidewalks, and you're right, challenging, managing that's going to be an interesting proposition. So I'm glad you're working on it, and ours is limited.
Not you.
Yeah, I just wanted to, since we are out of time, I wanted to wrap up with just a couple of things. First, I want to thank our partners who we could not do the things we do without their support. And so we have a great team here. I'm going to ask Joyce to bring up the slide of partners, and just to really thank them and their contributions to MassRobotics. We are blessed to have great partners that as I said, contribute both in funding but also in just expertise and information and lots of other things that allow us to deliver what we deliver. And then finally, just want to say that we're going to make this available. We're going to record this, we have recorded this. We're going to make it available on our website. And so if you missed that information, as I said, we're going to be addressing the questions that we received. We got a number in that we just didn't have a chance to get to, and we'll send that information out. If you want to be part of our efforts, please do so. Join us and